Welcome to the simulator video for the Sensors, Effectors, and Actuators Part 1, where we focused on analog and digital signals. So now I'm going to go through a couple different simulations based upon to give you like hands-on and based upon what we did in the actual notes itself. So for all of these, some steps may look complex, but be aware the key part of what I want you to get out of this is more the understanding of the analog and digital signals and the general idea of hooking these up. A few of these simulations deal with some new components and give you a basic idea of how to work with them, and future lectures will go over a little bit more examples of, well, how do we deal, say, with a button better, and providing some helpful code so you can move forwards in dealing with some of the complex tasks. Now, this first simulation that I want to take a look at quickly is just going back to the photoresistor. So again, this is a resistor that changes resistance based upon the actual amount of light that it's receiving. And it's an example of something that we could use as an analog sensor input and use it as a way to detect changes in light. Now, it is not a perfect light sensor, but it's a cheap and easy one to begin with. Now, what this circuit here is, just want to show you, just like in the notes, it showed you a schematic diagram of like just setting up just a whole circuit where you had an LED and you had the light resistor in place, and showing that you could play around with it and set up a circuit that then would fade the light based upon like input from, boom, this little photoresistor here. Now, point again here is just to demonstrate that everything we're doing with controller, you could build a direct circuit to do exactly what you want, but the controllers that we're using Arduino allow us to have it be reprogrammable. So, starting here, we know your power source of a 9 volt, we have our usual power going to the anode on the LED, and then running this time through the cathode is that we have the photoresistor here and here. And now when we start running the simulation, and this is where it's different than if you're dealing with this physical devices, and so when you get to that, you'll see where I work with an actual photoresistor. But if we start with this one here, it doesn't seem like much is happening. What you have to do is, in the simulator, you have to click on the actual resistor itself, which is actually some input, and then you need to move this slider, which is simulating a change in the light that it's actually receiving. So right now it's at dark to high. So the fact that this is dark, light's not on. If we change this, you can see the light slowly going up to a certain level and coming back down. So nothing major here, but just showing the fact of this light input that's changing an actual resistor. Not so impressive in the simulator, but when we look at the physical work, you'll see an actual one in play, and how the simulators don't always show everything you need to know. We have this first idea of this analog signal that it will change as you have these inputs. If it would like nighttime, day, back to nighttime, blah. Okay. Now I'm going to go back, and now, well, we want to step this up. That's just a basic circuit we dealt with in the beginning, but how could we actually hook this up to an Arduino itself and connect it to the analog inputs and start reading that analog signal that's coming in? So taking samples from it and using that information then to do some kind of work. In this case, it won't be anything like too fancy. We're just going to go right here as first one and just connect it where it's working with an LED this time. But instead of this time being that the photoresistor is directly connected to the actual LED, instead it is being used that it's connected into the inputs for the actual Arduino. Then we have code then that we can change that based upon the signal decide what happens when it's actually sent out to the LED. So we have our Arduino here, and what we have in effect here is two different circuits. So this is one board connecting everything together. We have the one circuit that we have our LED with the resistor connecting to the ground, and then completing that, it's being controlled on pin 3. Now, key thing for right now is why I have it on pin 3 is you can see again that is a PWM pin. So it'll allow us to then simulate an analog signal going out and basically in effect fade the light. Because if we give it different levels of the actual current going to it, boom, it'll change the level of actual light that's going into it. Now, the photoresistor that we see here, same as the one we had before, it is then hooked up that we have power that's being shared going through one end, and coming the other end is connected down to the actual A pin. This little resistor that you see here that's connected to ground is called a voltage divider. You don't need to know more about this, but it's just the fact that this is supposed to drop the actual voltage so that the Arduino can read it properly. If you want to do something similar, you can just set up a similar circuit. So on the same line that you have the resistor on, you have it connected as the analog input. And this time I just went a 470k ohm, and this was following a tutorial that's in the code itself. It suggests to do this, just a lower one. And so it lowers the actual voltage and allows that the Arduino can pick it up properly from right here. So we have it hooked to A0, and we have this one in actual fade. Now, if I open up the code itself, I'll step you through it. So this time, instead of you watching me type it all, I have everything ready to go for you here. Let's see if I can increase. Yeah, increases the font somewhat. And so you have, again, some constants, which I suggest to have in all of your code. LED pin is on 3, and then we have the photoresistor, and I'm just saying it's on A0 and having these easy constants for later on. Coming down here, we see another example where I've decided to have some output of information, which will also allow us to graph some of the data. So I want to show you the serial monitor and serial plotter as they are in the simulator itself. So begin setting it up. We have that 9600 baud rate. So again, that 9600 bits per second is being transmitted is what we're saying. We're setting our LED as output in this case, so now that we're sending information to it. And then just as a beginning value for the graphs going out, I am putting a 0 and 0. And these are just going to be the output levels that we actually have. So there's a 0 for the first graph line and a 0 for the second. Now for the simulator here, you're only going to see one line, which is this first value. It doesn't handle multiple lines. But if you were to hook up a similar circuit on the physical Arduino and use an Arduino IDE, you would see two actual graph lines off of this. Coming into our loop function, which will repeat indefinitely, is that we read from the analog pin. So we have an analog read, we have the photoresistor pin, and we're getting a reading coming back. And remember, by default, it should be a value between 0 and 1023. It's from the minimum to the maximum actual value. After this, what I'm getting the code to do is, well, I want it to just read in. So this is our sense part of our kind of sense, think, act. And then next we have our kind of think, which is very rudimentary, just doing some quick work. And then we have our act section down here. So sense, read in and take a sample from the analog stream at this point in time. More signals could be coming in after this while we're doing work, but we're saying analog read us a value to come in. Next, using the map function, I remember that takes your value here that should be between this range, and it maps it to an equivalent value that's between this range here from min to max. So this first one here, I have a couple others that we'll play around with, but I have this first one right here, which is our reading of that actual resistor value and try to map it. And now remember why I'm doing this mapping is I want to change it from being a reading that's between 0 to 1023 and then be the equivalent value between 0 to 255, which is the range for values you can send out on a PWM pin. After this, I am just outputting the reading value, then a tab to separate it, and then this line right here at the println to print out the actual mapped light value. So in the serial monitor, we'll be able to see the two values. When we open up the serial plotter, we won't be able to see it at all. So here's our little bit of really quick think that's coming in. So again, sense, this is our think, and then following after is our quick action, which is then just to take our mapped light level and send it out the LED, and then delay for a very fractional amount so that we can see that change, and it's also not just the simulator going crazy. Okay, so I'm going to run the code without opening the monitors or anything, and then we can see what's actually happening. For right now, I'm just going to zoom in on the breadboard so we can do all our work here and see everything a lot easier. So start simulation. Wow, we can see it's slightly dim, and remember now we have to click on the photoresistor here, which is dark, and if we increase this, we get a nominal increase and decrease in the actual LED. Boom, due to that resistor here. Maybe to make this a little bit higher, we'll change the resistance of that one so it's not bugging it so much. Boom. Come back here, so that's high. We go down to low, so now it's a little bit more noticeable. So it's changing that to a 1k ohm instead of that 100k I had. So going up, going down. So the important one that makes this different than the previous circuit where it's hooked up to the actual 9-volt battery is that it's what's coming in here for these values, and we decide in our code what's going to happen and then sending it out. So we have our sensor, we have our controller physically here, and we have our actual effector that's changing the outside environment. So that's our body of the robot so far, and what it's doing for its sense, think, act, reading the value, thinking and changing the value and outputting some stuff, and then coming back here. Okay. Now let's stop the simulation. Now, to see the actual serial monitor itself, that is just down here at the bottom. So I just shrunk the window down so it's easier to see. So you have to click on this one, and it's going to open up the actual serial monitor. The serial plotter in here then can be opened up down here in the bottom right. Boom. Click here, and we can clear all values. So it's different than what you'll see for the Arduino IDE, but it's our starting point. Okay. And I should, if we align this right, just be able to increase this just a little bit so that we can just see what's happening here. Boom. Okay, so our serial monitor output will be here. We have our serial plotter. I'm just going to close the serial plotter right now so we can see what's going on right here. So if I start the simulation, it's just now every time after that delay is outputting the value. So this is what it's reading currently from the photoresistor, its value, and then this is the value that it's mapping it to. So that equivalence, the result from that map function. So if we go in once again, zoom in and change the photoresistor, we can see, oh, see the values going up as we're doing this and the corresponding change. But this isn't so interesting. This is that analog, and it's going to be consistent as nothing else changes. So not as interesting to see these values, but it's an example of showing you, well, okay, if I have this code right here, what am I going to see on that actual output? But if we open up the serial plotter, when we make these changes, then we're going to see a little bit more. So you can actually see it starting to graph those values out. So right now, we're just right here at that, boom, 270. Yeah, the 870 right here, and so it's just staying consistency. So it's only when it gets a change coming from the environment, which I am simulating or making by doing this slider just to represent actual change in light, we can see the plotter values going up. So the serial monitor is good for seeing some output and monitoring, but if you have a whole bunch of numbers like this, and you want to see, well, what's really happening and have a memory of over time, the serial plotter is really useful to check and see what's going on. And we'll see this even better when we go to the physical work video. So you can see me playing around, and as if I was doing that analog, and like sudden change, really bright, really dark, really bright, really dark. How fun. And like these jitteriness, and as it keeps going. Okay. So you have your first example there of doing, like, working with any kind of analog input. And the key part is it's really just about hooking it up to these analog input pins, using the analog read, and then if we want to do anything with PWM to simulate it, is having an analog write over here. So just because this is a photoresistor, if we change it to another analog input, it's still going to be like connecting up to here, and you still have these same reads. The difference is that I've designed the circuit, and I know that, hey, what I've got hooked to this pin is a photoresistor, and I'm working with light, so this is why I'm coding to translate the values and change it outwards. So based upon your design and what sensor you have hooked up, you know what you want to do with that actual read value, all that's coming in. So you can see, again, it's a combination of what you have for the circuit for that sensor to hook it up and what it takes. And this, again, was me looking it up from a tutorial. You can go to it itself where I got the information, hook this up, and explains it a little bit more. And you can copy similar things from that circuit to get this kind of resistor going in. So it's your basic analog, your basic PWM pin, and seeing that actual effect. And that's first out of everything we've done of the robotic cycle. So let's step that up even more. So that was just working with the photoresistor and doing some work. Let's now go and see, well, what's the next step that we can do? So we did the photoresistor, and then next we want to go with doing a basic button as a digital input. So we had analog inputs before, so we had the light here to control, but now this time we have this button, and a button is just press down, signal go through, press up, let go, or vice versa, depending on the type of button you're working with. is a digital input. Now again, most of these you find when you read about the actual sensor. They say they're analog, they say how it's connected, or say it's digital and where you connect to it. So for this, here again we have two circuits, one again for being the LED. I have left it on pin 3 for PWM, which doesn't matter here. Like, we could read a digital input and then write code to send out the PWM to do some fading action, like when the buttons press, fade up, or so forth. But in this case, I'm just going to have it where it turns the light on. So if before doing anything else, I'll just show it actually running. And we can see here, hit the button, light goes on, let go of the button, it stops. To make that easier to see, I will change the resistance here again, so I'm lowering it. So it has much resistance, but enough to stop the LED from blowing up. Click run again, and we can see, boom. Press the button, goes on, press the button off, goes off. So I'm pressing it down just by clicking on it, boom. And we have that signal coming in. If we go to the code for this now, the difference here is, like, how do we set up and deal with the rest of the circuit? So with this one for setting up the button, again, don't worry about all the buttons and knowing everything about perfectly. I'll make a video about this in the future, and I'll give some extra code to make it easier to set up. But you can copy a similar structure where we have off of one pin. And it's going to always be hard to see if you're dealing with this physically, but on the simulator it's easy. Just put your mouse over the terminals and they tell you which side, that you have the 1A to 2B, 1B to 2B. And the idea is we have the gutter trench right here in the middle. These buttons are always nice to put in between the actual two. Don't put them down here, because this terminal and this terminal are connected and so forth for these ones, and you could have problems if you set it up improperly. So the idea here is that from 1A to 1B it's directly connected, and 2A to 2B is directly connected. But right now, with the button not being pressed, it's not completing the circuit through here. So it won't go and send any signal going up. So this one right now, and we have the power going from right here, and then we have a resistor right here, which is, again, it says in the actual code, I'll explain in a second, is just to deal with that for this button, it can read that digital input easily, the signal that there's been some actual kind of change. So it's just a basic 10k ohm resistor, and we have this on this other terminal, and the idea is that when we click this button, it's completing the circuit and also sending a signal through here that then can be read. And we have that on pin 7, non-PWM, doesn't really matter, we could have it on any one of these pins. I just picked number 7 here in the very beginning. So if we go to the code now, got this explanation here, another tutorial that you can look up if you want to go a little bit deeper into this resistors and the other setup. But we have a similar setup there before of constants again saying what pins. This value right here I'm just using as a global value so that when it's printing stuff out this time, it's just not going to print out every value that we're reading for the digital. It'll only print a value when it changes. So open a serial communication, set our pin mode for the LED for output, and we set the pin mode this time for the button to input, saying we want to read off of that actual pin. And then I want the light to be off at the very beginning of everything when we start the circuit, so I write a low, written out the LED pin to shut it off. Coming down to our next code, you have your digital read. So at the time of this function, it'll then pull and read a sample of what's coming in over line 7 and see, well, is it high or low? This code I've done right here is just checking to see, has our last value changed? So I put it at -1 because when you're reading, you're either going to get 0 or high. So like low or high. You'll never get a negative value. So I'm just having it as initial starting point, so it'll always keep the first value that's coming in and just checks, hey, is the new reading a different value from what we saw the last time from the previous value? Well, okay, if it is, then save it and write it out. And otherwise, if we come back here and it's like it hasn't changed, so the button has been pressed for a long time, it's not just going to keep printing out these like low values of 0. It is just going to only print it out when there's been a change. After that, so this is our sense, this is our think right here, combined with our act written inside of these here. So read, check if there's been a change in value and print it out, check the reading, and if it's high, being that the button's pressed, then send out a high to the actual LED. If it hasn't been pressed, then set it a low. Now be aware this is a very basic button example. This little if-else statement will not work really good if you're just trying to do a button presses or clicking that. There's issues of how long you hold your finger down for and how fast the Arduino's been reading that, and it may think that you've held it down for like 1 second, but it's been running so fast maybe it thought you pressed the button multiple times and it doesn't know that there's been a long press because we're at a low level, so you got to write that code yourself. But either way is that button's down, and while it's down it's high, and then when it's not pressed the light will go low, and then there's just a small delay here just so the simulator doesn't go crazy because we're having it run so fast. So very basic one, if we go and run the simulator again, the idea is, again, it's right now, this code is continuously running in our actual controller here, so again, and I'm not pressing it, so it's still doing the reading, and the idea is this read doesn't just sit there and wait until the button's pressed, it just reads whatever the current signal is coming over this line at this time. So with the button not being pressed, it'll be sending a low, so it goes here, it's a low, this value shouldn't have actually changed here, and then boom, we come in here, and it's going to check here, okay, it's not high, it's low, so it's writing out a low to it, and then delaying for 10 seconds. So as soon as I press it, and as long as I'm pressing it, it's going to keep reading this, seeing if the value's changed or not, and then checking which one it should be based upon the press and putting a light on. So while I'm holding this down, this isn't just one execution of the loop function. This will be multiple iterations of that actual loop. So until I do this, I let go and it goes back up to the reading and gets that actual low value. So next week we'll go over other examples of that's like debouncing buttons and all of that kind of fun if you're trying to use buttons in your project, which I always find to be painful for something that should be something that's actually simple. Now if I stop the simulator, I just want to open up the serial monitor so we can check the output for that. We have some extra things here already and I'm just going to clear it. And I'm just going to open up the serial plotter for fun just to see what it's going to do with this, because I didn't exactly design the output of the code to be meant for it, but I am curious. So we will start up the simulation, and you can see here beginning with it got a 0, which is that first read that it got off of there is a low, and so it's not going to output anything else because there hasn't been a change in the actual value. So until I hold this up, you can see the 1, and then you can see, okay, I've got a 1, and even though I'm holding it down, even though it keeps constantly getting a single of 1, it's not going to change and print out anything else till I output something different. And so hard to see on the plotter here that as I'm going, the ups and downs. And just for fun, because we're here, I'll close the monitor. And I'm just going to take this out so we can see, have a little bit fun, stop simulation, have a little fun with the plotter so we can really see the actual wave that's being generated for the output. So I'm just commenting everything out from here, and so it'll just print out whatever reading values it's getting. So again, I will open up the monitor. Here in this case, the plotter is the thing that we're only really caring about. So start the simulator. And now we're just getting a whole bunch of zeros. Nothing much is going to change on the plotter until I change this. And so you can see there, it's low, 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 high. And we're seeing that sequence, which is that kind of square wave. So if I have this up, then down, up, then down. So right here, button not pressed, button pressed, and voltage goes up. Bah. So this is just me mapping it on the output. Nothing too interesting there. So it's an example of a digital signal coming in. Now again, you don't need to be perfect about this right now. It'll take time of sitting down and playing around and hooking these up yourself. So going into the simulator, hooking it up, looking up tutorials for buttons and other digital sensors you want to work with. But you always have to understand, what's the schematic for hooking it up? How can I hook it up to the pins? Why are certain things there? How do I write the code to read from it? And right now, I want you to concentrate more of understand that difference of the digital and hooking it up, using the serial monitor, serial plotter, and some of the new functions that are here. So we'll step this up a notch. In the notes before, we went through analog signals, and we had like the basic photoresistor and kind of reading in from the analog device. We then went through digital, and then the next we ended off kind of dealing with PWM, which we already did in the first simulator, but I just wanted to throw in another one to play around with, and also something that can help you out if you're trying to fade a light up and showing it in two different ways. So I've got version 1 here where I'm going to do fading with a loop, and then I'm going to do version 2 here where I don't use like a for loop, but I actually use the built-in fact that the loop function is continuously going to actually fade the light up. So we'll go to version 1 right now. And what this is I'm throwing in a new component for you. That the kits come with as well. And what this is called is an RGB LED. So it's kind of hard to see. It looks clear here, has multiple lines coming off of it. What an RGB LED is that it combines red, green, and blue LEDs into one little device. So it looks like other LEDs you've worked with, but internally it can do red, green, blue, and you have different lines coming off of it. So you can go here and see, well, that line is for red, this line is for blue, and this line is for green, and then this one here is a cathode. So they have a common cathode being the negative, and then the rest of them are hooked up. And what it is that, again, through the voltage going through, they all come here and they all come out of here to complete the actual cycle. But depending upon how much actual voltage you apply to one pin, you get a certain brightness of that color. And the fact that lights blend together, and generally is that red, green, blue kind of thing, we can produce a whole bunch of different kind of light to a certain level of degree of quality, because these aren't, again, high level things. Now, to be aware is in the simulator, the RGB LED they show here has a common cathode. Now, there is another type of RGB LED, just to make things more confusing, where it's kind of similar setup that you have to look for the pins where they'll have one for red, green, blue, but they'll be a different order. But this common pin here is then instead for the anode being the positive. And so in that case, it just means you have to just tweak your code a little bit and change the circuit some. So in the simulator here, this is with an RGB LED that is a common cathode. And in the physical work ones, if you have the FreeNov kits, they have an RGB LED that has a common anode. Now, you may be wondering, like, how do I tell the difference? Well, if you hook it up and you get the wrong colors and nothing's working, good chance you probably need to switch around how you set things up and testing it out, or from what you buy. So again, physical simulator, you're going to be working with this similar circuit and have the fading, an RGB that says common cathode. If you have the FreeNov kits, you will have an RGB that has the anode, and in the physical work videos I go through that. So for this, we once again have resistors. This time I've set them up as really low at 1K. They're on each of the actual lines. So the individual anodes right here for, oh man, do not want that. Look at me just making a short circuit. Like that by clicking. So we have an individual here, we have the cycles, but now each one of these is then hooked up to PWM. I've also color coded the actual jumpers here just to make it easier to see, okay, what's connected to what. And here I only had to have the shared common ground. I didn't have to put here, I could have just put this ground straight to pin 13. I just wanted to use the common rail. It's my choice. So we'll zoom in more here. And then we'll open up the actual code. So in this case, still doing something that is with the PWMs that allows us to fade, because different levels of red, green, or blue allow for different colors to come out of this. And I've included some functions that you can take and use if you want. You need to modify. You need to realize that, like, even if this is for a task that we have in the course, you should be saying it's coming from me, and you should be documenting or changing it around to make it work for what you need to do. It's much better that you show that you've understand it than leaving a bunch of things in that doesn't work properly. So this one right here is going to be a function that you give it a pin, and it's going to go from 0 up to 255 in increments of 1. It's going to then do an analog write going out, so as long as this is up to a PWM pin, we're okay. And then it's going to say the level. It's going to delay for very minor amounts so that it doesn't flash really quickly. And at the very end, it's going to put a 0 just to turn off that light to make sure that there's no more light left after this. This function here that I've written just allows you, if you're doing RGB values, so looking them up, so different amounts of red, green, and blue, and just being able to automatically set that. So very useful for trying to set a specific color you're trying to look for. Then a little useful function that we could have just had these with zeros, but I just like having a more readable function, is call this, and it'll just turn off all the RGBs. Now, be aware is these values of zeros and stuff that we have in here is very specific to the RGB that has a common cathode. When you're working with one that's a common anode, like in the kits, there's different code, and you will find that in the physical work code section. Now, the actual loop function here this time is that in the very beginning, I'm just having it that go as that all lights off in the very beginning, and then it'll fade the red pin up, and then turn off, fade the blue pin up, then turn that one off, and fade up just the green pin, so we can see it going through its shades. And then here, I've gone to this website here. Anyone who's done web development, you understand RGB values, you've done your hex codes, getting 255, but the idea is you can go here and get a rough idea, and be aware, colors, everything, it's not going to look exactly the same when it comes out on the LED itself, but we're coming close. So here I picked one being a basic shade of yellow, kind of, and then it's going to delay for a second, then do a kind of basic pink, and then delay for a second. And then go back up and repeat these, and that's why I have this turn off, so we can repeat easily. Boom. So if we go through this simulator, just run it, you can see the red fading up, so the signal's coming through red, the blue's fading up, so the signal's coming through here, and then the green's fading up. Then you can see the yellow sitting there for a second, then the pink, and then looping back. So the idea is that you could have done this with like 3 separate LEDs, but this is using the RGB allows you then, well, I can use one, and then also have different shades of colors and play around with it in different ways to give information back to the outside actual environment. And it shows the PWM pins and the importance that if you're going to fade lights, they have to be a PWM, and shows you using this loop here how to fade a light up. But one thing I want to point out about this is that while you're doing this loop, you have no reads in here, so you're ignoring any signals that could be coming in if you had an analog sensor kind of connected. So here we have no sense, we just kind of having and we don't really have much think, we just have this action going. But the key thing is, even these 3 calls to this, is that it's just come here running this for loop, and this entire for loop just keeps stepping up and fading, stepping up and fading, stepping and fading. And if while we were doing this, even if it was just a few milliseconds or 1 millisecond, there were changes in the actual analog sensor that we want to, or digital sensor that we wanted to actually access, you're going to miss them. It's not going to happen because this is running for too long. So it's kind of like being distracted by something and you're just fading, doing the work, and ignoring that there's some action happening on somewhere else. So we'll play around with that, and that's just important to take into account now. Now, for the simulator work right now, I am kind of going through it a little bit faster in this video, but the point is that you should be able to have access to all of these simulators, so you can go into the code and you can play around with it, and you have access to the code itself if you want to try doing this on the actual physical devices. And you should sit down and play with these. You should change the code, get it to try to get it doing something differently, and become a little bit more familiar with what's going on, and then send me any questions that you have. So I'm going to stop this one, and we're going to go back to the last one for the simulator work, which is going to take the same setup that we have now, but instead of using a for loop that continuously goes, we're instead going to do a little bit of work of okay, we'll fade a little bit and come back, fade a little bit and come back, and fade a little bit and come back. And do it a little differently. So what this one's going to do now is going to fade up and then fade down for a color. And you could modify this to work if you just wanted to just fade up. You're going to have to understand what's going on in the code. And I've tried to not have everything in main and break it up into functions and make it a little bit more usable for different aspects. And if you want to use it yourself, you have to make sure you take out what's not important to what you're working on. So back, we're here, same circuit we had before, but this time if we go into the code, this is where the bigger changes are. So we still have the same kind of pin kind of setup right here. What I've done here now is made some constants to keep track of, well, am I fading up or fading down? Because what this one's going to do, if we start running the actual simulator, you can see it fading up, and then after a specific point in time, it's going to start fading down. So step fade, checking for that one. And so you can see it fading back up. And so it's doing this in slight increments. We can make it go faster by changing some actual delays. And it's just doing it with one pin for right now. So we set everything up. But what's going to be important for this is like, well, what do we do with the actual fades going step by step? So one is I'm having it fade up and down, and just to make things more readable, I make some constants. I'm using booleans just because I either fade up being true and fade down being false. I could use an integer, but we only have two states we're kind of working with, of fading up or fading down. So boolean works. You only have to have two values. I am now keeping in another global variable to keep track of for the controller, what am I currently doing? So am I fading up or am I fading down? I'm setting to fading up. I have this variable here to keep track of what's the current pin that I want to fade up. So you can play around with this if you wanted to have it fade other pins. And I wanted to keep track of what's the current light level. And this is the idea is like, well, every iteration of that loop, I have to think of what do I need to keep track of, which is 1, I'm fading up. So what's the task I'm doing? Fading up. 2, what light to fade up. And 3, what level is it currently at? And that's why it's important they're global and up here. Then have the normal setup for outputs, turning everything off. And then here, this is still a little function to make it readable. What is the start of the fade? So if this is the very beginning of doing a fade, what should everything be set to? So this start fade here is just checking, am I fading up or am I fading down? So it's fading up. Well, you should be at the lowest level first. So it sets the level you're fading from 0 and then just prints it out to the screen. This is just so that we can do some debugging. Otherwise, it should be fading down. So it should be going from the highest value being 255 and then go from there. And then it sends out that very first beginning level. So if you were just trying to fade something up, you don't need all of this. You're really just going to have to set it at 0 and start up from this. It's just this example is showing where I can fade up and then fade down. So from low to high, then from high back down to low. So that's that start fade. The step fade function here is just doing what is one increment of changing the fade. So in the for loop, it was just incrementing it, then outputting automatically. The step here, you kind of think of it as like the internals of that actual for loop that we had in the previous example. And we're just checking, okay, am I fading up? If I'm fading up, well, then I should be increasing the level by an amount, in this case 1. Otherwise, if I'm fading down, I want to decrease by 1. I'm just printing out that value, so for debugging we can see what's going on, and then doing the analog write going to the current LED that we have that should be in a PWM pin and delaying for a bit before we go to the next one. Oops. The check for state change function that you're seeing here is basically something to see like, okay, am I right here is like, am I fading up and I've reached the maximum? So I should be done. And so if I faded up, well, instead then I'm going to switch my task now to be fading down and then have it reset what the fading down should be just to be sure that everything is set up properly if any values went weird. Otherwise, if I was fading down and I hit 0, well then I should change my state to fading up and reset the start of what's coming back next. So again, if you were doing fading up, there's a lot more stuff that you could cut out of all this. This is just to make a step through. And then we finally have the loop function down here at the bottom. And the idea is that this is always continuously running. So in the very beginning first setup, we set for fading up. It's going to call like step fade, which is then going to check, okay, step fade, am I fading up? So increment or decrement, output the value, do the analog write. And then we have the check for state change to see, have I reached the end? And if I have reached the end, then change to another state. Being, okay, if I was up, then fade down. If I was fade down, go back to fade up. And so forth. And so this will just continuously keep happening this. And the idea that this is just one step from the fading. So we're not really doing any sense in thinking. Like, we're doing here of like step of doing some thinking and then acting at the same time. And then we're doing a little bit more thinking right here, saying, should we change the state of what we're doing and before we go back up to the next step? You could throw in now a sense step here where we do this and make some changes. And the idea is that as it's fading, you could still read in the sensor value and then change the state if something came in based upon that sensor value. So that's a preamble for me. It's a lot of talking, but don't worry. I'm just saying this as a beginning introduction to this, because I will have future lectures where we go over more of, well, if I start thinking of these states and these steps and doing a little bit of sense, think, act, what do we do? And right now, let's say we change around a few things, that it was the red pin. Let's change it instead to be the actual green pin. Start the simulation. And now you can see it slowly fading up by increments of 1 until we get to the actual max brightness. And then we will slowly see it start fading down. So you can see it from here fading down slightly. Here it's not as noticeable because we're doing like these delays of 10 and only going up by 1. So like that's a lot of time from right here. So we could go to our step fade and change this instead to I'm going to go plus equals 5. So add 5 to it every time. And here minus equals 5. Subtract 5 from it each time. So we'll see it start fading up faster and then start fading down faster from there. So you can see it fading down and then fading up and then fading down, fading up, fading down, fading up, fading down, fading up. Okay. So stop there. So from here, you should move on to the physical work videos. And even again, if you only use a simulator, I still suggest you go to the actual physical videos so that you can see everything that's happening as well. And I also throw in extra information into every video. Otherwise from that, continue being excellent people, and I hope you're all doing okay. And if you're not, just reach out to me and talk to me.